Hi, so in this video what we'll be doing is, so this is a fresh GCP account which has been set up and just the card details have been entered to get 33,000 credits. Now if you do it with your college account, you will get extra credits. Like if any free user on a Gmail @gmail.com does it, he gets around 23,000, 24,000. But if you do it with your Pilani account, you get almost 33,000. So I would highly recommend log into your GCP with this. Now, as soon as you do it, it will ask you to activate full account, which is very much required. So just click on activate full account and it says activated successfully and you can now continue. So the first thing which we need to do, so the first thing which we need to do is go to the IM admin account, and there you'll see this section called quotas. So generally all these resources are limited and everything here is set to a limit. So what we need to actually search for is metric with the name GPU all. So the metric which we have to search for GPUs underscore all. So why we're not able to see this option is because actually we've not enabled because this is just a fresh account, so nothing has been enabled on this right now. So first we need to enable the APIs which we are using. So by default this compute engine API is disabled, so therefore we're not able to see it in the quota. So first you'll need to actually enable this compute engine API. Usually it takes almost a minute to do so. So after we have enabled the compute engine, which is basically nothing but which will be the virtual computer which is running on a Google Cloud. So what we can do now is go to the IM admin, and again this time we'll go to quotas, and now if we search for GPUs all, you'll get this quota and this limit is set to 0, which means as of now you're not allowed to put any GPU on your cloud. So what we'll do is we'll edit this quota. Click on edit quota. To use this API you may need credit. Alright, so we've already, so we can checkbox this and click on edit quotas, and now you can see the quota GPUs all region. So we'll set the new limit to 1 and some request description we can write running deploying ML model for you. Based on your project which you have, you can type anything. I'm typing something simple, and you can now type the phone number. So phone number, I'll just pause the video and type it. So we've submitted this request, and usually Google Cloud takes, I mean, it almost does it instantaneously. So let's refresh it and see whether our quota has run. You will be notified on your email address as well. So now you can see that the limit is set to 1. So now we're all good to actually launch the VM instance. For this, we'll click on create instance, and so in new VM instance, we'll just type the name of the instance as I've given it the name Tarish GCP. For location, it is important that we choose the right location because GPUs are not available everywhere. So for now, I'm choosing US East 4. I'm not 100% sure whether the GPU access will be available here or not. Then for the machine configuration, I would choose GPU, and here I would choose NVIDIA T4. The number of GPUs which I'm using is 1. And for the memory requirements, the kind of application which we are dealing with, we would want 8 CPUs and 30 GB of RAM, so we'll select this. Then for the boot disk, we'll actually use our standard Ubuntu, because here we're sure of what will be compatible or not, and here we're not going to choose ARM64, we're going to choose standard x86 architecture, because most of the softwares which we see are available for x86/64, which is basically the AMD and Intel processors and not the ARM processors. ARM processors generally available for NVIDIA Jetson or those kind of embedded devices. We'll choose x86. Then boot disk type, we'll choose balanced persistent disk, and here we'll type 200 and just click on select. Here we'll allow HTTP traffic, HTTPS traffic, and for now we'll do this. So the monthly estimate is around $429, which is well within the budget which has been ordered to us. So even if we spend this much monthly, still it's fine. Like we won't be keeping the GPU running all the time. So yeah, let's click on create. So here if the error comes, then we just have to switch the location to. So as you can see that the status is tick marked and we've got an external IP address and we can SSH into this. But before we do all of this, let me just actually go inside this instance And so here, this is the external IP address, and the network tags which it is currently supporting is HTTP and HTTPS, because we've switched that on. And besides that, the SSH keys we need to add. So any configuration settings which we have done, we can simply go here to the edit and we can edit the info. So the first thing which I would like to add to this whole instance is an SSH key. So here it is asking first to enter the public SSH key. So those who are on Linux or use PuTTY, like there are multiple ways you can just Google on how to get a public and a private SSH key. Now it supports two formats, RSA and ECDSA. So I would prefer doing it with RSA. So I'll just show you how to do that. So the command which you'll be using if you're on Linux, you can simply use this SSH keygen, and the encoding, the encryption scheme which we'll be using is RSA, which is a standard scheme, and the file name which we'll keep, let's call it Taresh SSH. So, and you can distribute these keys amongst yourself. So it's asking enter passphrase. So I'm not keeping enter any passphrase. So now it says that file or direct. Okay, so I think I made this error. .ssh is after. So now the key fingerprint it has given, and obviously it is generated using this local PC. So this thing is coming here, and the keys random art image, all things it has displayed. So I can go to the home folder. Here we can go in .ssh. So there'll be two keys, Taresh key, which is the private key, and the public. So whatever is coming in the public key, I can open this terminal. So this is what the public key looks like. Obviously, as long as I don't give you the private key, public key is meant to be public, so it can be put anywhere. As long as I don't give you the private, cannot do much with this public key anyways. So I'll put this public key, and then in the end I can put the user account of this. So 2020-95. Okay, so this SSH key is now, we've stored this SSH key. Now the last thing which is remaining in here is to actually do a network configuration in which we allow all the ports on this save this. So once we have saved this key, we can you can just install, I'm guessing most of you are already using Visual Studio Code by now. You can connect, click on connect to host, and configure SSH hosts and the SSH file, and then whatever name you want to. So this does not matter. Here I'll write Tarish TCP GPU and the public address of public address. The username would be the email ID. So that would, and this key here, now what we'll be using instead of this key is just the Tarish. So we've saved this. Now let's try to connect with this host, see if we're able to do that. Before that, by the way, like just to let you know, there are multiple ways to SSH into this. So if I just simply click on SSH here, so I can get access to my VM on the browser itself. So anytime, like on my mobile phone or anywhere, wherever I can log in commands. Basically, it's like a code heavy machine which is able to run machine learning tasks readily available in your pocket. So you can see that the name of the PC Taresh GCP is coming here, and the name of the user is coming, correct? So this is how we do the SSH from the browser. Obviously the better way to do it using VS Code. So let's see if the keys which we have created, whether they work or not. So it's asking me to so I can see it's installing VS Code. So basically we're able to run this. Now after this, everything which we'll be doing mostly here. So now we're already inside his server. If I click on new terminal, you can see I'll be able to open his terminal, and I can open the base folder. So anything which I do, I have the file system access to me, I have a terminal access to me, and I have a code editor. So basically there is no third thing which is required, and VS Code handles everything. So obviously first thing which we want to check is whether our GPU is available here or not. So by the now we cannot use NVIDIA SMI as of, because NVIDIA drivers are not installed in here, but we can definitely check out whether a GPU is available here or not. So the command to do that is lspci grep vgn. Okay, so I see that there's a NVIDIA GPU Tesla T4 available here. Only thing is that its drivers are not installed yet. So to install the drivers, it's very simple. So basically what the machine we're getting is host install. So finally we want to run Vitis AI. So what is the better resource than this to actually do the installation? So it's telling us to, this is the option which we are interested in, CUDA capable GPUs. So CUDA is the library by NVIDIA, and ROCm is the library by AMD. Obviously CUDA is like CUDA is proprietary software and it is not open source. But what AMD is, like why AMD is coming into the picture is because they have made this an open source. So people can actually directly accelerate, interact with GPUs on the go. So which is a really big thing for community to have an open source thing. So first of all, we'll execute these three commands. We need to add a sudo in front of it. Then sudo apt install media driver, and I will install the version 535. So on cloud computer, internet speed is not an issue because it's super fast. You get super fast here. After this, we'll have to reboot the system once. So while it is rebooting, we'll quickly go and we'll go to this machine, and here in more action. So here in more actions, there is a option called as view network details. So in order to do any network related activity, we need to enable the API, network analysis API. So we'll enable this API, and then so these are all the default networking things which are allowed. Now usually our homes have a router. Like why can't we do this on the home computer? Because that is a residential IP which we get, which is meant for our security. But all these cloud computers and everything, they have static IPs available with them, which can be accessed from it. So therefore, this is for them. It's not an issue to provide us with a static IP, and we can explore this further. So here we can go to the firewall. Like you can directly search for firewall here also, but you can search for firewall from here as well. So we'll create a firewall rule, and we'll call it custom ports description opening all the ports on the cloud computer. And priority, the lower the number, the higher the priority. So the network is default by default, and direction of traffic is ingress, incoming action, and action on match is allow. So basically, as a DevOps engineer, many of you might be looking for this kind of a job. For a DevOps engineer, these are all the operations which they have to do, like those who are working in the cloud and everything, like which all IPs to allow, which computer can connect to which computer, making clusters and everything. So I'll say in the target all instances in the network, source filters, and here I have to type the IP address. So 0.0.0.0/0 means allow all the IP address, and protocols and ports allow all the. So I'll just create this firewall rule. In the meanwhile, let's just look at the VS. So yeah, now NVIDIA SMI will not run directly. We'll have to do a reboot. So I'll just type sudo reboot, and let's just wait for so as soon as we rebooted, obviously this VS code will say cannot connect, please reload. So after a minute or so we'll reload. So now we've reloaded the window, and you can see that we have a GPU running with us on the cloud. And now there are, like, n number of possibilities which you can do. So as a basic test of, like, as a just a basic proof of whether this thing is working properly or not, we'll just install Anaconda on the base machine without we'll just install the Anaconda on the base. So here we'll go to this installer, and 64-bit x86 installer. We'll copy link address, and we'll just type wget Anaconda. So you can see this downloading speed is almost 270 280. So it has saved this. Now we can type bash Anaconda. You have to be really careful at the last enter. So here we have to type yes. It will ask at which location we want to install. So we're giving it the default Anaconda 3 look. It is doing that, it is installing. So it will take around 2-3 minutes to install. So let's just pause the video till that time. So now the installation of Anaconda is complete, and you can undo this by typing coordinate reversal. Okay, so we'll just check the bash rc file one, and whether conda. So you can see that this entry has been made by conda. So now if we create a new terminal, then automatically the bash rc is the file which automatically gets invoked. So here if I do conda, then it is able to identify my conda. So these are all the packages which are installed in your base folder. Obviously Pytorch is not yet installed in this, but Python and everything is installed for installing. So I'll just do one thing. I'll create a conda create -n. I'll create a new environment called Pytorch, and yeah, I'll just create this, and we can head over to Pytorch started. So for us to install, our version is CUDA 12.1. How do we know this? Because if we type NVIDIA SMI on this, we'll see that the CUDA version is 12.2. So 12.1, 12.2 is similar. So for us, the command is simple: pip3 install torch version and torch order. So along with all the packages, I'm just downloading. And it's been some time since we have done a sudo apt update and a sudo apt upgrade. So it would be a good time to actually update the packages which are installed in our Ubuntu. So by the way, whatever we have done till now on the cloud computer and everything, all this can be captured through a script, and this is known as a GCP script. So whenever you open a new terminal or like whatever you want to do, you can just enable, you can just try, you can export this whole thing as a script, and you just have to execute one single command, and a new computer with new everything that will come automatically. So I have not done that part right now, but if anyone of you does that, they can help others with that script, so you don't have to go through all this installation time manually. Like everything can be automated with the script. So now we'll just do one thing. We'll type Jupyter notebook. Actually, I created an environment, but I forgot to change to that environment, so it's just that I have the base with me, right? So yeah, you can see that you have the ports, like it is running here on port 8888, and you have this port forwarded with you 8889. So first thing which we can just quickly try out is opening this host, and it's asking for password or token. So that token you can copy from here. Yeah, so now you're inside this environment, and I can click on new Python 3 curve, and I can simply write a small machine learning code for me to test out. So you can see that number of available GPUs is 1, and the name of that GPU is Tesla T. So it's a good thing to actually, like, have your GPU available on the cloud, and always remember to keep pausing, or keep that machine flexible, because unnecessarily you don't want it to get charged, because GPU cost is high, like charging 489 per month. But if you use it wisely, like for whatever time you're training or everything, you can possibly extend these credits to your whole 3-month period. That being said, now it's time to actually launch the Vitis AI GitHub link. So again, here is the guide for that. So first it is telling us to install the Docker. To install the Docker, I have a really good resource which is available, which has been made available to all of you. How to install Vivado, Vitis and Vitis AI quick. So here you can scroll down to the Docker, and we can execute these commands. Not containerizing an application, like you won't be able to understand the importance of it right now, but working with Dockers and containers is the future of computing. So I would highly recommend that you all get a skill set. And lastly, instead of this user, I would just type the name of this current user, which is F2020. After this step, we'll have to restart the Docker service once. For restarting, we can just use some ctl restart docker. If I type groups, then okay, so I need to do a sudo reboot for group configuration to actually take place. So yeah, so our system has restarted, and obviously the Jupyter notebook which we would have created must be shut down by now. But now you can see that a Docker group is added to the to our user, and we can verify the Docker installation just by typing docker and hello world, and it says yeah, hello from Docker, which means Docker is perfectly installed. Now the next phase, the last phase of this starts, which is Vitis AI GitHub repo. So I'll just do git clone. While it is doing the git clone, I will open another terminal, and one command in here was remaining to be executed, which was apt install NVIDIA container. If it is giving this error, which mostly it will give it to you because it is giving to me as well, then you can I've just searched this thing on Google, and it has given, if you scroll below, so this answer, if you follow this, it will help you. Basically every command in the Ubuntu has to be is in a repo, and that repo has to be authorized by your computer to be added. So until unless you do that, it will not happen. So now you can see that the last command which we entered, which was this, was the same command, NVIDIA Container Toolkit, and now this is. So the files are also installed, and the NVIDIA Container Toolkit is also installed. We just need to go now to the Vitis AI folder. Inside there we'll see the Docker folder. We'll go inside there, and we'll type sudo /docker build.s. so it is asking us to choose the -t and the -f option. So at -t, since I'm working on Pytorch right now, so I'll type Pytorch. You can build everything, it's not like you can build everything in this. And -t I'll type GPU, and -f I will type Pytorch. So now it will take approx 10 minutes for this whole container to be, a Docker container to be built, and later on we'll just do the port forwarding on this Docker. So when we run the Docker image now, what will happen is when we run the Jupyter notebook on the Docker, which is built by Xilinx, so we'll get access to all the Vitis AI, all the commands which Vitis AI uses. We'll get access to that for the compilation of the xmodel file, for the creation of xmodel file. Along with that, what we'll get is port forwarding. So we'll do this port forwarding, and now at a particular port running on our computer, we'll be able to access that Jupyter node. So this will make things very easy for us. One last thing, or else, like, that is it, what is required from our side. One thing more we can do is, since we have used custom ports to allow all the ports to be enabled, we can while we're initializing the Jupyter notebook, so let's do that, how that is. So if I type Jupyter notebook password, so it's asking me to put a password. I'll put password for, so it wrote the hash of the password to this particular thing, and this I can find it in the Jupyter notebook configuration. So now in the notebook app, what I see here, I can also write a few more commands here which will allow any IP address in the world to get connected to it. So if I add these two commands in here, IP and the port, so I'll be using port 8889 to launch my Jupyter notebook, and the password of this is obviously set. So here it will listen to all the IP addresses. So I can just click on Control S, save, and now if I run a Jupyter notebook, let me just verify this. So online it says first we have to click on generate config. So here a generate config file will be available. Now in this file we'll have to search for here. So here we'll have to set few things. I'll just tell which all. So here we can simply search for Control F. We can search for a property called IP. So right now it's committed to localhost, and we can type 0.0.0 for allowing all IP addresses. In a similar way, we can just search for port, and here it is telling us that the default port is 888. We set it to 888, and also I see that the password is also there. So I'll just copy this to here and uncomment this. So forces users to use a password for the notebook server. Okay, now if I try to run the, okay, so now it says that it is running on Pytorch GCP 8889 as expected, and the proof of this whole thing would be when we are able to see this running on the like directly on the cloud, like anyone can access. So let's copy this key and type 888. Okay, so now you can also type this on your laptop: 34.86.166.158:8889. Okay, so now basically anyone can run this. So I have a student sitting next to me, and he's not connected to any of these things. Still he is able to run everything on the Jupyter notebook, which is like a really cool thing to do. And he has an access to a Jupyter notebook which is able to run which has a GPU in it basically. Okay, so let's since this thing is sorted, now let's just finally look at but by the way, this imposes certain security issues, because now anyone will be available to the whole world wide web. So anyone can start typing random passwords and eventually will be able to crack. But we don't have any sensitive files here, so it's fine. Like, this is not, so that's why you need to understand why putting a personal computer onto a world wide web becomes very a security challenge. Therefore we are assigned residential IP addresses, and we have a router, and the router has a public IP address, and then it internalizes the IP addresses of all the machines which are connected. So like you might be seeing 192.0. something related to that. So that is internal IP address which the router has, and the router has an inbuilt firewall which does not allow everything to flow. So that is made as a security thing, because if you put your laptop onto the internet directly, it will be at a huge security. So this is almost done. I think it takes about some 600 seconds or 300 seconds to almost 5 minutes. So let's pause the video and wait for it. So this whole package has been built now, and if we type docker images, then we'll see two images are formed. Obviously we'll choose the 131 GB one. This is the accurate but before doing this, in the Vitis AI folder, we have a script called docker run.sh. So in the docker run.sh, right now the ports are not forwarded in this script. So we'll just enter the commands for port forward. So the command for that is -p, whatever ports you want to forward. And let me forward one more port, 7. So these three ports I am forwarding from the Docker machine to the outside. So I can type /docker run.sh. I can type this colon this tag. So let me just debug this. Okay, so the issue was that it had to be just given a sudo reboot, because remember we had installed NVIDIA container toolkit, and after installing the NVIDIA container toolkit we had not rebooted the system. So now this Vitis AI is up and running, the Vitis AI version 3.5, the GPU, everything is correctly loaded. Here if I type Jupyter notebook generate, what was that command, generate hyphen config, so it has written this to the folder here, so I can sudo apt install man in this file. So around line 3 there is a search facility also in this, but I've never, because we are inside the Docker, therefore we cannot directly use the code editor to edit it. So that is Control W search. So here in the IP address we need to type again 0.0.0. Next thing which you have to search for is port, on which port we are wanting to launch. So Control W. There has to be another port. There are multiple places. Let's search for the complete Control W notebook app dot not found. Wow. Okay, let's anyways we'll launch it on the default port. Server app we have IP. So I think based on this on the version of which we are using, everything is server app here. On which port do you want to launch? 8887. Let's control. So by the way, we have not forwarded any ports. If you remember, we've not forwarded any ports in here. So we need to forward the ports for it to get reflected, or else you won't be able to access this. So let me tell you a few quick things. If you press Control P, Control Q, you will be detached from the Docker. So if I type docker ps, so Docker is running in the background, but I'm detached from that. And if some of you it is not working, that is because in the preferences in keyboard shortcuts you already have assigned Control plus P for something. So I have just deleted that. Control P and Control Q, whatever you have assigned to Control P and Control Q, just delete that. Okay, so now you have detached from this Docker, and now what you can do is you can just commit to this Docker. So whatever changes you have made, they will remain as it. So command for that is docker commit command. So the command to commit the Docker is simple: docker commit. You type the container ID. So here is the container ID, and then you can give it some name. So here, since I'll write it simply Pytorch latest, Pytorch Vitis AI, just to differentiate. And you can actually, just like in GitHub, you export the code of you can commit it and push it to the remote origin. You can do the same thing here as well. So it's like your whole operating system is being pushed or pulled, and others can also access that. So by the way, like if you don't want to build, I can push this Docker image as well, and others simply pull it, because why we are building the Docker image is because based on the CPU configuration, GPU configuration, RAM and this whole image is built. Now if it is already pre-built, like for like everyone who's using this GPU, they can simply Docker pull my whole thing and they don't have to run it. But it's good to actually run. Why is this? So it took around 1 minute or so for it to complete this. So now this Docker image is running. So we can stop the existing Docker image from docker stop and just pass in this container ID. So yeah, now if I type docker ps, everything is stopped. So let me add a -p. Let me add -888 and 77. I'm saving this file now. And by the way, if we want certain more things to be enabled here, we can do that. So basically you see that /workspace is coming in the starting. That is because it is telling start here as the /workspace. So, and then it is importing certain things like Xilinx DSA, it is importing as DSA, overlay bins it is importing as overlay bins. So these files are being exposed to the Docker. So Docker is a very secure way of running the whole application. So now I'll relaunch my /docker run.sh, and this time I will latest AI latest. I can keep committing to the same tag. It's not an issue. I can keep committing to the same tag. All right, perfect. So now what we have to do is launch Jupyter Notebook. So it says your application is running on port 8887, and this port, the best part about Jupyter Notebook is that it automatically forwards the port. So if I just open it here, then it will ask me to do the login. Obviously this time I have not set the password because I have not typed the whole password thing. So what you can simply do is you can go to your terminal and can copy this token, right? And you can run it on your laptop. You can go to 8887 port, the same public IP address, port 8887. But the only thing is I will have to send you this thing something token, yeah, before you can log in, but at least you can just as a proof of concept you can try. So in the demos folder, just to show you, in the demos folder I will actually, what I'll do is, we have the ping dpu basic mnsit. So this is written in TensorFlow. This is written in TensorFlow. We don't for running something on Pytorch. So actually, what, let's do one thing. Let's stop this video here, and your whole setup and environment is up and running and you're able to create and everything. So in the next video, we'll run a Pytorch code from the starting, from the scratch, generate the xmodel file, and then use the FPGA board which is kept here to run that. Like, we'll choose a pre-existing image, so we won't be training the entire thing. All right, so thank you for